Around 350 BC, the Greek philosopher Aristotle wrote about a process to distill fresh water from seawater. He found that hanging sponges over boiling seawater would collect the vapor of the steam. When these sponges were removed and wrung out, they yielded fresh water. This process is called distillation. Distillation is the separation of one substance from another based on the difference in boiling points between the two substances. Long ago, it was realized that alcohol and water have different boiling points. In a typical still, the water and alcohol in the heated mash would separate because alcohol has a lower boiling point. This alcoholic vapor would then flow through a condenser, which was usually submerged in cool water. This change in temperature would cause the vapor to condense to liquid. Today, commercial distilleries operate under modern sanitary conditions. Distillation equipment and techniques have been modernized, but the basic process of distillation remains the same. In order to understand this process, it is useful to first consider the theoretical basis for distillation. In any liquid, some of the molecules have enough energy to overcome intermolecular attractions and leave the surface of the liquid, so that part of the liquid vaporizes. As this process occurs, the pressure exerted by the vapor molecules rises. In a closed container, some of the molecules which have vaporized may strike the surface of the liquid and be recaptured. These molecules have condensed on the liquid surface. When the rate at which the liquid vaporizes is equal to the rate at which condensation occurs, the system is at equilibrium. The pressure of gas above the liquid under these conditions is called the vapor pressure of the liquid. When the temperature of a liquid is increased, more molecules have sufficient energy to overcome the intermolecular attractions and can escape to the gas phase. Thus, as the temperature is increased, the vapor pressure of the substance rises. At some temperature, the vapor pressure of the liquid equals the external pressure, and the liquid boils. The temperature at which this occurs is called the boiling point.
Simple distillations are performed routinely in the laboratory with apparatus that is commonly available. The flask selected for the distillation should have a round bottom or a pear shape and be of such a size that the material to be distilled fills it between 1/2 and 2/3 full. These flasks have advantages over flasks with flat bottoms. First, the material will be heated in a uniform manner, and the possibility of localized heating is reduced. Second, as the material is boiled away, the material that is left will be concentrated at the bottom of the flask and not spread out over a large surface area. The flask that is selected is clamped to a rigid stand. Additionally, large flasks are supported by an iron ring or a heating mantle. The liquid to be distilled is placed in the flask, and a few boiling chips made of porous, inert material are added. These chips provide a large surface area where boiling can be started. This helps to prevent the possibility of the liquid superheating and subsequently boiling erratically or bumping. Very often, glassware with standard taper ground glass joints is used in the organic laboratory. Because of the precision required to manufacture this uniformly sized equipment, it is very expensive. Care must be taken at all times when using this glassware. Depending on the conditions of the experiment, it may be necessary to grease the joints before the glassware is assembled. This grease provides a tighter seal for the joint. However, one runs a risk of contaminating the reactants or products whenever grease is used in the joints. If you are instructed to grease the joints on your glassware, a very light film should be applied evenly over the full ground glass surface. After the flask is filled, a Y-shaped distillation head is placed in the flask with a smaller opening directly above the center of the flask. This head serves two purposes. It connects the flask to the condenser and also holds a thermometer in the vapors which rise from the flask during the distillation. The boiling point of the material that is distilling can thus be observed. Next, the condenser is attached to the distillation head and clamped loosely to another support stand. The condenser should rest on the bottom of the clamp so that it can be tightened from the top when final adjustments are made. An adapter is used to lead the condensed material to a collection vessel. This adapter is also loosely clamped during the initial setup of the apparatus. All the equipment must be secured tightly before the distillation. However, it must be aligned first to prevent stress on the joints, which may result in leaks or broken apparatus. To align the apparatus, first view the setup end-on to make sure that all the equipment is in a vertical plane. Straighten any twists. Then carefully tighten the clamps a little at a time in succession. Some small pieces of glassware, such as this collection vessel, have hooks and can be attached to the adapter by rubber bands or springs. When the equipment has been aligned and tightened, an adapter is placed at the top of the distillation head and the thermometer carefully placed in it. The top of the bulb of the thermometer should be set even with the bottom of the sidearm opening of the head. In this way, the heated vapors which will form during the distillation will pass over the thermometer bulb. If the bulb is placed too high, the vapors will not reach it, and the observed boiling point will be too low. If it is placed too low, the correct boiling point of the collected distillate may not be obtained. A heat source is then placed under the round bottom flask. Several sources may be used depending on the equipment available and the expected boiling point of the distillate. Commonly used heat sources include a heat lamp, a heating mantle, a water bath, an oil bath, or a steam bath. Water passes through the condenser in order to cool the vapors as they come over during the distillation. Flexible tubing is connected from the lower end of the condenser to a water source, and a second length of tubing is connected from the upper end of the condenser to a drain. The water must flow into the lower end of the jacket of the condenser to ensure proper cooling of the distillate vapors. The water should flow through the condenser continuously, but slowly. If the water flows too fast, it puts too much pressure on the tubing and connections, and they may come apart during the distillation. After the apparatus is put together, the water flow is slowly started through the condenser. It is always wise to check the assembly carefully before beginning the distillation. Check that the top of the thermometer bulb is properly placed in the distillation head, the assembly is clamped and supported and properly aligned in a vertical plane. None of the connections have been opened during the tightening process. Boiling chips have been placed in the flask. The adapter is open to the atmosphere so that pressure will not build up during the distillation. And finally, that the water is running through the condenser jacket. Once all of these items have been checked, the heat source can now be turned on. Because a distillation must be monitored, it should be continually watched and never left unattended. As the liquid begins to boil, the hot vapors rise up the sides of the flask and into the distillation head. As they reach cooler portions of the apparatus, the vapors condense and return to the flask. They also heat up the apparatus so that the next portion of vapors rises higher than the preceding portion. Eventually, all of the apparatus is warm and the hot vapors pass over the thermometer bulb. There is a sudden rise in the temperature shown by the thermometer reading when the hot vapors reach the thermometer bulb. As the hot vapors of the distillate move through the water-cooled condenser, they liquefy. The distillate runs through the adapter into the collection vessel. The temperature observed when the first drop of distillate is collected is recorded as the beginning of the temperature range for the distillate. The distillation is continued until the desired amount of distillate is collected. The highest temperature reached while this distillate is being collected is recorded as the top of the boiling point range of the distillate. If the first few drops of distillate come over at a much lower temperature than the major portion of the distillate, it is advisable to collect these drops in a separate container. At any time during the distillation, the process may be stopped by either turning off or removing the heat source. However, The distillation must be stopped before the distilling flask is heated to dryness. If the flask is heated to dryness, it may break. Also, the residues remaining in the bottom of the flask often decompose or may be explosive. Thus, it is important to leave a small amount of liquid in the distilling flask.
Distillation is one of the basic techniques for separating one substance from another. Although the techniques and apparatus have changed since Aristotle's time, the basic process remains the same.